one, we're going to find the exact length of the polar curve r equals 2 times 1 plus 2 cosine of theta. I'm going to go ahead and right away just write this as 2 plus 2 cosine of theta. This is a cardioid, and it encompasses all 4 quadrants. So we're going to go from 0 to 2 pi and take the square root of r squared. So it's going to be 2 plus 2 cosine of theta squared, plus the derivative of this is going to be negative 2 sine of theta squared d theta. Now let's expand this perfect square trinomial. For the first part, that's going to give you 4 plus 8 cosine of theta plus 4 cosine squared of theta plus, for this piece, 4 sine squared of theta, d theta. Now a little side note here, for this piece I'm just going to write this as 4 times cosine squared plus sine squared. And this just equals 1. So this whole thing here is just going to be 4, and I'm going to rewrite this as the integral from 0 to 2 pi, and we're going to have 4 plus 4 is 8. So this is going to be 8 plus 8 cosine of theta d theta. Now, I can also, as a side note, factor out an 8 and get 1 plus cosine theta. All right, so what I'm going to do is pull out the 8 and a square root of 8. So we're going to have, let's pull it out, square root of 8 times the integral from 0 to 2 pi. Now that we have that, I pulled out this square root of 8. Inside I have square root of 1 plus cosine of theta. Now I'm going to use my trig identity and rewrite this as 2 square root of 2 times 1/2 1 plus cosine of theta, d theta. Now I didn't change anything, I just decided to write this as 2 times 1 divided by 2. So now I can write this part as cosine squared of theta divided by 2, because we don't have a 2 right here. So let's do that, and I'll show you what I mean. Let's see. We're going to get the integral square root of 8 times the integral of 0 to 2 pi, and this is going to be the square root of 2 times cosine squared of theta divided by 2. We have to divide it by 2 because our formula had a 2 in it, d theta. Now I can pull out the square root of 2, so this is going to be square root of 8 times square root of 2 times the integral from 0 to 2 pi. Since it's square and this is square root, I can write this as absolute value of cosine of theta divided by 2 d theta. All right, now let's see what I did wrong. Yeah, it's green. All right. Now what we're going to do is write this as, let's see. Once we have this, by symmetry, what I can do, since cosine is symmetric to the x-axis, I can write this as 2 times square root of 16. I'm just multiplying those two. And instead of going from 0 to 2 pi, go to 0 to pi. So I'm just going to multiply it and just do half the upper half of it. And then just multiply by 2 to get the lower half. And then just have cosine theta divided by 2 d theta. This is 4. So basically we're going to have 4 times 2 is 8. And now let's integrate this. So that's going to be 2 sine of theta divided by 2. And we're evaluating from 0 to pi. And again, I did this step due to symmetry. All right. Now evaluating this, we're going to get cosine of pi, sine of pi. We're going to have 8 times 2 sine of pi divided by 2 minus 2 sine of 0 divided by 2. So this goes away. Sine of pi divided by 2 is 1. So you're going to get 8 times 2, because 2 times 1 is 2, equals 16. So that's your exact length of the curve. And that's it. Thank you. Have a nice day. Bye-bye.